Okay, in this video we're going to be doing Calc AB problem set number 110. The problems in a playlist are in the description below. Let's see what we're doing. So number one, set up but do not solve or evaluate an equation that gives the value of k, where the line x equals k divides the region bounded by f of x equals the quantity x minus 5 squared and g of x equals 4x minus 7 into two regions with equal areas. Okay, so we're going to need to know where these things intersect. So that's f of x equals g of x, quantity x minus 5 squared equals 4x minus 7. I don't know, expand it. X squared minus 10x plus 25 is equal to 4x minus 7. Move everything to one side. So x squared minus 14x plus 32 is equal to 0. I'm pretty sure this does not factor, so quadratic formula. We got opposite of b plus or minus the square root, b squared minus 4ac, so minus 128 all over 2. This simplifies to 7 plus or minus root 17. I'll leave it to you to try that. So we know the two intersection points are going to be at 7 minus root 17 and then 7 plus root 17. Our picture, we have a quadratic that opens up and a linear function with a positive slope, so it looks kind of like that. So we want to go from, we need k to be in between those values and split this region exactly in half. It's really tempting to say that k is probably 7. It's almost certainly not 7 because there's like a lack of symmetry there. But we can set it up. So we're going to go from the left-hand point to k of top take away bottom, which is g of x minus f of x. Since we're not solving it and we've correctly identified the functions, I don't think we need to write the functions. And then we're going to go from k to 7 plus root 17. G of x minus f of x. So the functions were named in the problem. There's nothing wrong with using their names. It's less messy. I recommend it. I think I would leave my answer like this. So let's check out the next problem. All right, calculator, find the area of the region in the first quadrant bounded by y equals sine of x and y equals x over 3. I'm literally just going to use a calculator for this. So I graphed the two functions. I found their intersection points using menu 814. I use a TI Inspire CX2 CAS. Any calculator can find those intersection points, though. I'm not sure any calculator can find the bounded area, but the Inspire can. So then I found the bounded area, which I think is menu 6.8. So then I'm going to write it down. So the area that we got is 0.785 because of 3 decimals. So 0, 2, 2.27886. I just wrote as many as I could see because I didn't want to round that thing. Of top takeaway bottom. And 0.785. There's nothing more you need to do on that problem. You just need to understand how to use your calculator to do the calculus. All right, next up. Find the area of the region bounded by y equals e to the x, y equals 6, and the y-axis. All right, so I'm going to draw this one. E to the x looks like that, 6 looks like that, and the y-axis, so it's that like almost triangular region or almost a sector of a circle, but it's neither of those. So I need to know the intersection point. So e to the x equals 6. Natural log of both sides gives me x equals natural log of 6. So my ordered pair is the natural log of 6 comma 6. And you can do this with respect to x, and if you can do a problem with respect to x, it's almost always like mentally easier, even if it's harder to do. So I'm going to do that. So integral from 0 to the natural log of 6 of the top curve is 6, the bottom is e to the x, so top takeaway bottom. We integrate, we get 6x minus e to the x from 0 to the natural log of 6. We have to plug in the natural log of 6. We'll get 6 natural log of 6 minus e to the natural log of 6. I think you could leave that, but like it definitely simplifies. And then minus, when you plug in 0, you don't like 0 out the whole thing. Like 6 times 0 is 0. E to the 0 is 1. So make sure you're on top of that. I see a lot of people forget that. So 6 natural log of 6. E to the natural log of 6 is just 6 because e and natural log are inverse functions. And so if you do f of f inverse of blah, you just get blah. So e to the natural log of 6 is 6. And then e to the 0 is 1, but we have minus negative 1. And then collect. So 6 natural log of 6 minus 5. Weird area, but like, you know, it's a weird shape. All right, next up. Find the average rate of change, which is algebra 1 slope, on the interval from 9 to 30 for g of x equals the integral from 6 to x of 1 over the square root of t minus 6. I'm looking at this now and I'm realizing this problem sort of doesn't work. It's like more complicated than I meant it to be because 6 is a vertical asymptote for this thing. But I'm going to continue and do the problem anyway because that doesn't impact the answer that we get. But like I really should have done maybe 7 to x. That would have been like a cleaner problem. So be aware the problem kind of has some issues and I would have to like think about it again. But I'm going to just go for it and pretend that conversation didn't happen. So average rate of change is algebra 1 slope. It's going to be g of 30 minus g of 9 over 30 minus 9. And then that's going to be, so g of 30 is the integral from 6 to 30 of this thing. And then g of 9 is the integral from 6 to 9 of this thing. And that's why like the 6 as the lower bound doesn't really matter because you're going from 6 to 30, you're going from 6 to 9. So really you're just going from 9 to 30 and it like takes that problem out of our hands. But I probably should have thought about it more, but I didn't. But I bet if you're looking at the PDF, I might have changed that number. Who knows? All right, so there's going to be a 1 over 21 just kind of hanging around. I'm going to make it t minus 6 to the negative 1/2. So I'm doing this in my head. T minus 6 to the negative 1/2 plus 1 times the reciprocal is to the positive 1/2 and times 2. So we're going to get 2 square root t minus 6 all over 21. And we're going from 9 to 30. And this does not clean up. We just get 2 over 21. When you plug in 30, you get root 24. When you plug in 9, you get root 3. You can simplify square root of 24, but it doesn't get any better than that. So that's it. That's the whole problem set. I hope this was helpful, and good luck.